Okay, this week we're going to be solving, let me get here with my slides here. We're going to be solving polynomials with uh, powers greater than 2, so it's not a quadratic anymore. So we could have, like, if you have 4 terms, I think the best thing to do is to factor it by grouping, and that would be something like if I took this problem here. Let me turn my mic or my marker on here. This I would probably put inside parentheses. I'd put this sign inside parentheses and this inside parentheses, and then I'd factor out the greatest common factor. So, and this is what is called factoring by grouping. We're grouping 2 terms together and then 2 terms together, and then I'm going to pull out an x squared here. So I'm left with an x minus 3 here plus, and then I'm going to pull out a 3 here. And that leaves me with x minus 3. Now, oops. This only works if these 2 parentheses are exactly the same. When we factor out a term, and if those parentheses are not the same, then it doesn't work. But this time they happen to be the same thing, so I'm going to factor out the x minus 3 because they're the same in both sets, and I'm left with x squared plus 3 is equal to 0. I'm not done yet. I've just factored it. This is a 3rd degree polynomial, so that means I know I'm looking for 3 solutions, because the highest power always tells us how many solutions we should be looking for. So in this problem, 3 is a solution, so that's a pretty easy one. But this one, I'm not sure what makes it equal to 0. So over to the side, I just put x squared plus 3 is equal to 0. Subtract off 3. Now it's something, my answer is going to be very similar to something like last week. Good afternoon, Olivia. Boy, the last couple of weeks I didn't have anybody. 2 people is amazing. So then I have x squared is equal to negative 3, but if we take the square root of both sides, guess what? When you take the square root of a negative number, it's going to be an imaginary answer. So I'm going to end up with x equals plus or minus the square root of 3i. So how many solutions do I have? 1 here, 2 here. So that means that gives me 3 solutions. 3 is a solution. Positive square root of 3i is a solution, and negative square root of 3i is a solution. So that means when I'm dealing with a polynomial with a degree higher than 2, if it's a 3 or a 4, that's how many solutions I'm looking for. So solving by grouping, if you're ever term, you really want to solving by grouping, and that's just an example there. All right, let's take a look at another one. I'm not sure what this stands for here. Discrete. Oops. What that means. Okay. Then we're going to be solving radical equations this week also. The basic strategy for solving a radical equation is to isolate the radical term first and then raise both sides of the equation to a power to remove the radical. So for example, if I gave you something like, let's say, I'll give you an easy one to start with. Let's say I gave you of x is equal to 16. Well, the radical is already isolated, so now I could take both sides. Oops, I don't want to go 16 because that's going to be too high. Let's go 4. So the radical is all by itself, so I'm going to square both sides, and that leaves me with x equals 16. Now, in that problem, the radical was already by itself. Now, let's say I gave you something like this. Let's say I give you 2 times the square root of x plus 4 is, minus 10 is equal to 20. Okay? So now the radical's not all by itself. There's a 2 on this side. There's a minus 10 on this side. I've got to get those numbers out of there before I can square everything. So I'm going to add 10 to both sides. So now I'm left with 2, the square root of x plus 4 is equal to 30. Then now I'm going to get rid of the 2, and to do that, I'm going to divide through by 2 here. So the square root of x plus 4 is equal to 15. Now I've isolated the radical, so I can now square both sides to get rid of the radical. So now I'm left with x plus 4 is equal to 15 squared, which I believe is 225. Subtract 4 from both sides, and I end up with x equals 221. So when you're solving a radical equation, you want to isolate the radical. And we'll be going through some of these problems in the practice this week. And then we're also going to be solving, oh, here's an example. In this problem, if I was going to solve this problem, first thing I'm going to do is I'm going to add 9 to both sides. So I'm left with 12. The square root of x equals 9. Then I divide through by 12. So I end up with the square root of x equals 9/12. So I'd probably reduce that before I square everything. So 3 goes out of 9 3 times, 3 goes into 12 4 times. Okay. Then I'm going to square both sides. So x equals, well, when you square a fraction, you just square the top and bottom. So that's going to be 9/16. And that would be my answer. So if you're solving a radical, you want to isolate the radical and then square both sides. We're also dealing with rational equations this week. Okay, so a rational equation is where you have a fraction. My guess, or I would suggest that you always multiply every single term by the lowest common denominator. In this problem, or the greatest common factor, so here I'm going to use x. Oops, got to turn my marker on again. I'm going to use x times. And why am I going to do that? Well, if I multiply this term by x minus 2, and this term by x minus 2, I also have to multiply this term by x minus 2, because you have to multiply every single term. So what happens here is the x's cross out. So I'm left with 2x minus 2 is equal to, and here the x minus 2 crosses out this x minus 2, so I'm just left with 3x minus, and this one I'm still left with the x because there's nothing in the denominator, so I'm just left with x minus 2. Now, why is that nice? Well, look what happened. Now I'm left with just a regular equation. It's no longer a rational equation. So whenever you get a problem like that, the best thing to do is to multiply by the lowest common denominator, and that gets rid of all of your denominators, and then you can solve the equation. Okay? All right. So this week, let me get you the code for this week. All right. So here's the code for week's Desmos lessons. It's in the chat box. So if you click on that, we can work through all of the problems off of the practice for this week. Okay. So let's take a look at some of the problems. I want to be on slide number, oops, I have to share my screen. Sorry about that. Chrome tab, be here. Okay. All right. So the first thing that we want to do here is, let's see here. So I've got main lesson 6. I'm good here. All right. So what we want to do is we want to do the first problem on the practice. Now, this first problem, it is a polynomial function. Okay. And in order to solve this polynomial function, I'm looking at it, it's like, okay, it's not a one that has 4 terms, so I can't solve it by grouping. So then it's like, okay, when I solve a problem like this, first thing I do is I always think about what is the greatest common factor that I can factor out. Well, if I have a 6x to the 4th minus 10x squared is equal to 0, I'm going to factor out a 2x squared. Okay, so factor out the greatest common factor. That leaves me the 3x squared minus 5 is equal to 0. Well, I know one of the answers. Anytime you have something factored out that has a variable in it, 0 is a solution. Well, since this is x to the 4th, I know that 2 of my answers, since it's x squared, 2 of my answers are 0. So I have 0, 0. Usually we don't write down 0, 0, but it is 2 times. I mean, there. But then I also have to figure out what this is. So I'm just going to set this equal to 0. 3x squared minus 5 equals 0. Bring the 5 over. 3x squared equals 5. Divide through by 3. So x squared equals 5/3. Now I can take the square root of both sides. So my answer is x equals plus or minus the square root of 5 over the square root of 3. Now, why did I break it up that way? The reason I broke it up that way is because I'm looking over at the left-hand side. I'm looking at the answers, and there's nothing that had the square root of 5 over the square root of 3. So it's like, okay, they're going to simplify this answer. And when you simplify radicals, you aren't supposed to have a radical in the denominator. So I'm just going to multiply top and bottom by the square root of 3. So that gives me the square root of 15 on top. On the bottom, square root of 3 times square root of 3 is 3. So my answer is going to be plus or minus the square root of 15 over 3 and 0. So my answer key 0 and plus or minus square root of 15. So I'm going to go with letter A for that one. Does that make sense? Okay, does that make sense? Uh-oh, nobody's saying anything. Okay. All right. So that's problem number 1 off the practice this week. Let's go to problem number 2. Problem number 2 is very similar, but I think it's a little bit easier. I've got x to the 4th minus 625. Well, you've got x to the 4th, so I know there's 4 solutions to my problem. Okay, so right off the bat, I just put down 4 solutions. That's what I'm looking for. Okay, I've got x to the 4th minus 625 is equal to 0. I'm just going to move the 625 over, so x to the 4th equals 625. Then I'm going to just do the square root to start with. Okay, if I take the square root, I end up with x squared is equal to, well, the square root of 625, is that 25? Is that 25? 25 times 25. I think it's right. 10, that's 12. That's 10. That's 4, 5, 625. Yep. So this is going to be 25, plus or minus. So really, I have x squared equals positive 25. And I also have x squared equals negative 25. So now if I take the square root again, I end up with x equals positive and negative 5. If I take the square root again here, I end up with x equals plus or minus 5i. Oh no. That's just like last week. Remember last week we dealt with imaginary numbers? So positive 5, negative 5, positive 5i, negative 5i. So it looks like letter C, if I'm not mistaken. And that does give me 4 solutions. And I knew I had to look for 4 solutions because it was x to the 4th power. All right. Problem number 3. Okay, so now we have a polynomial to a degree higher than 2, and it has 4 terms. So my thinking is that we should be using grouping to solve this problem. Okay, so if I'm going to use grouping, first thing I do is I just group the first 2 terms together. So I've got x to the 3rd minus 5x squared. And then plus, and then I'm going to change this and make that a negative x there. So negative x plus 5. I'm going to factor out an x squared here. And I'm left with x minus 5 plus, I don't have to factor anything out here, but I'm going to leave the 1 so I can see it. Well, no, I'm going to factor out a negative 1. So that, because I know I have to get it to be x minus 5. So if I factor out a negative 1, I'm left with x minus 5. Because if these 2 parentheses are not the same, factoring by grouping does not work. So if I factor out a negative 1 here, it leaves me with x minus 5, which is perfect. So now I'm going to factor out the x minus 5. I'm left with x squared minus 1. X equals 5. And then here, x squared minus 1, that factors down to x minus 1, x plus 1, difference of 2 squares. So I've got 1 and negative 1 as solutions also. So now I have 3 solutions. I have 5, 1, and negative 1. So I solved by grouping. So anytime you have more than 1 or 4 terms, you want to solve by grouping. All right. I've done a lot of the work so far. I'm going to let you guys work on the next couple. Any questions so far? Okay. Let's go to problem number 4 on the practice. I'm going to let you guys work on this one. Number 4, it says solve the following equation for x. Okay. So I'm going to multiply every single term by the greatest common denominator, and I would go with x plus 2. So what I'd like you guys to do is work on this problem and see what you get. When you get an answer, just throw it in the chat box, and then we'll talk about the problem. Okay. Did either of you guys get an answer for this problem? Or still working on it? Okay. If I was going to do this problem, I'm looking at it and it's like, okay, I've got x plus 2, so I know all of the denominators are going to cross off. So I'm going to multiply by x plus 2 here, x plus 2 here, x plus 2 here. And lo and behold, that crosses out, that crosses out, that crosses out. So I'm just left with x equals x squared minus 6. Well, this is a quadratic. We always know in order to solve a quadratic, it has to be studied. I'm just going to subtract an x from both sides. So I'm left with 0 is equal to x squared minus 1x minus 6. Now, this is an easy problem to factor, so I'm just going to factor it. What two numbers multiply negative 6 that adds up to negative 1? Well, negative 3 and 2. So I've got x minus 3, x plus 2. So x equals 3 is a solution, and x equals negative 2 is a solution. Now, this is where you might get an extraneous solution. What does that mean? Well, it means that when you plug it in, it makes the problem not true. So for example, if I took negative 2 here, and I plugged it in here, I end up with x over 0 is equal to x squared over 0 minus 6 over 0. Well, we know we can't divide by 0. So that is an extraneous solution. It doesn't work. That one's gone. So my answer is just 3. So my answer should just be letter A for this problem. Okay. All right. Let's try number 5 on the assessment. Number 5 is a radical problem. Now, this week, you're going to have polynomial functions, radical functions, and rational functions to solve. This one should be a little bit easier. All right. I'm going to turn off my mic, let you guys work on this one, see what you get. All right. Any questions or any solutions to this problem? Now this one, since everything is underneath the radical, we say that the radical is isolated. Okay, it's already isolated. You cannot get rid of the 2 underneath that bracket symbol. Just can't do that. So right away, I can just square both sides. So if I square both sides, I end up with 2x equals 16. Divide through by 2, I end up with x equals 8, which is letter D. All right, number 6 on the practice for this week. Another radical problem. I think we did this one. Yeah, was this the one that we did in class just a while ago? I think it is. We had 12 the square root of x. I didn't give it. It wasn't a multiple choice question, but I think it was the same thing. So we added 9 to both sides. We're isolating the radical. So we end up with 12 the square root of x is equal to 9. Divide through by 12. I ended up with the square root of x equals 9 halves, which I'm going to simplify down to 3/4. And then I'm going to square both sides. And when you square a fraction, you just square the top. It's going to be 9 over 16. Or letter E. All right. Again, I've been talking a lot. I'm gonna be quiet. I'm gonna ask if there's any questions. You guys have any questions, or are you guys okay? You guys are way too quiet. I don't know if you're there or not. You're okay. All right. Thank you for chatting back. I'm so used to my Algebra 2 class when I have like 40 kids in there. They're all asking questions at the same time. It's a little different. All right. Number 7 on this week's practice, we have find all the solutions of the equation. Check your solutions in the original equation. Now, obviously, you don't have to check your answers. But in this problem, I've got a radical. So I've got the square root of 4 minus x minus 3 is equal to 0. Everything that's underneath the radical can't move. But I can move this plus 3. So I'm just going to add a 3 to both sides. So I'm left with the square root of 4 minus x equals 3. Now the radical is isolated, so I can square both sides. And I'm left with 4 minus x equals 9. Subtract 4 from both sides. Negative x equals 5. Divide through by negative 1. X equals negative 5. Now, Let's check our solution. So if I put -5 in there, 4 minus the -5 is 4 plus 5. That's 9. The square root of 9 is 3. It works. So our answer is correct. Number 8. It's a tough problem. Well, it's not real tough, but it is harder than most. I'm going to give you guys some time to. Okay. What is the low? What are you going to multiply every single term by? And the reason we do that is to get rid of the denominators. We don't want denominators in our problem. So if we multiply by the lowest common denominator, the denominators cross off. So what is the lowest common denominator there? What are you going to multiply every single term by? And I will give you a hint. This is what you should multiply you should multiply by 7x plus 3. That is your lowest common denominator. So multiply every term by 7 times x plus 3, and then I will come back in a little bit and we'll go over the problem. All right, let's go through this one. So now what I would have done is I would have multiplied every single term by 7x plus 3. So I'm going to write out the problem first. Let's see if I can make this a little bit thinner here. I don't know if I can or not. Let's try this one. Okay, so I've got x plus 4 over 7 minus x plus 4 over x plus 3 is equal to 0. Now that 0 is going to make it easy because anything you multiply by 0 is going to be just 0. So now I'm going to multiply every term by 7 x plus 3, 7 x plus 3, 7 x plus 3. All right, so in this problem, the 7's cross out. So I'm left with x plus 4 times x plus 3 minus, well, here the x plus 3's cross out, So I'm left with 7x plus 4 is equal to, well, 0 times anything is 0. All right, so now I've gotten rid of the denominator. Is this an easy problem still? No, I mean, it's still going to be tough. So I have to do FOIL here. So that's going to give me x squared plus 7x plus 12 minus, and then 7x minus 28 is equal to 0. So it's a quadratic. I'm going to combine like terms. Well, that 7x and that negative 7x is going to be gone. So I'm left with x squared, negative 28 and 12. That gives me negative 16. It's equal to 0. So difference two squares, x plus 4, x minus 4. So my answer is x equals 4 or negative 4. Letter B. Puts a lot of things together. I mean, when you think about it, you're looking at this problem and it's like, okay, first thing, I've got to get rid of the denominators. Okay, got rid of them. Second thing, I've got to multiply using FOIL to get rid of those parentheses. And I got to combine like terms, factor. This is when I, as a teacher, this is the type of problem that shows me if a student really understands solving rational equations, because you've got to know a lot of different things in order to solve that. There's a lot going on in that problem. So that is an awesome problem. Any questions on that problem? Anything that did not make sense that I did? Don't be shy. I mean, if there's something that doesn't make sense, please say something. I mean, I will not be offended. All right, let's go on to problem number 9 on this week's practice. Number 9, we have solve the equation for x. Okay, remember, when we have a radical equation, we want to isolate the radical. That means get it by itself. So I'm going to add 3 to both sides. So I'm left with the square root of x minus 4 is equal to negative 2. Now, this is where I stop. When you isolate your radical, and if it's equal to a negative number, that was with absolute values. Can I have a negative come out of a radical? I don't think so. I think we're going to say there's no solution here, right? Because if I square this, let's just continue on. If I square this, both sides, I end up with x minus 4 is equal to 4. Subtract off 4, so x, or add 4, so x equals 8. Okay? Now, let's go back to the original problem. Let's put 8 in here. See if it works. So I've got the square root of 8 minus 4 minus 3 is equal to negative 5. So 8 minus 4, square root of 4 minus 3 is equal to negative 5. Square root of 4 is 2, so 2 minus 3 is equal to negative 5. That is not true. 2 minus 3 does not equal negative 5. There's no solution here. I mean, we could solve it. It looks like there's an answer, right? I mean, it looks like we got an answer to the problem, but if you plug that back in, it doesn't really work. I mean, you're not going to end up with a radical equaling a negative number. It just can't happen. Okay, so my answer there should be no solution. Okay, any questions on that? All right. Here is probably one of the hardest problems that, I mean, I do have a problem like this on the assessment. The radical is isolated, but I have an x on both sides now. And when you have an x on both sides, then it's not going to be an easy problem, because it's going to square it. You're going to end up having to square both sides. So if I had x plus 3 is equal to the square root of 12x plus 1, the radical is isolated. There's no numbers on the outside, so I'm just going to square both sides now. Well, if I square both sides now, I end up with x plus 3 squared, which really is x plus 3 times x plus 3 is equal to, and this one, this side is nice because the radical and the square cross off, so I end up with 2x minus, or 12x plus 1. So now I'm going to factor this out. This gives me, I'm sorry, I'm going to FOIL it. So I get x squared plus 6x plus 9 is equal to 12x plus 1. It's a quadratic, so in order to solve a quadratic, I have to get it set equal to 0. So I'm going to subtract off 12x. So this gives me x squared minus 6x, and I'm going to subtract off the 1 also. So that minus 1 there, so that's plus 8 is equal to 0, because we have to get it set equal to 0 in order to solve. Set equal to 0. Now I'm going to factor it. So it looks like negative 4 times negative 2 is equal to positive 8. Negative 4 plus negative 2 is negative 6. So I have x minus 4, x minus 2 here. So my solutions are x equals 4, x equals 2. So letter D should be the correct answer. Whew. That is all of the practice problems for this week. Any questions on the practice problems? Anyone that you want to go through again that you did not understand what I was doing? So the assessment is set up pretty straightforward this week. The first type of problems are just polynomials where you either factor it or solve by grouping. And the second set is radical equations, and the third set are rational equations. Very straightforward. Boom, boom, boom. Do these types of problems. All right. If there's no other questions, you guys have a great week. I hope to see you back next week. Same place, same time. Bye.